All right. So welcome to this week's Megaport Live Tech Drop-In. This week we're going to have a look at ExpressRoute. We're going to do a bit of an overview, and we will have a look at how you can then connect to ExpressRoute via Megaport. So it'll be reasonably technical, but sort of still somewhat of a high-level overview. And then at the end we'll do a Q&A. So basically what we'll look at is a very quick kind of summary of where Megaport fits into the whole situation, and then the ExpressRoute architecture. We'll go through the locations, how the circuit works, and the edge devices, and how you can set up high availability and the different options you have there and pros and cons. We'll have a look at the different SKUs that are available, the different tiers of ExpressRoute, and then do a demo. And as I mentioned, a Q&A at the end. So if you have any questions, either via Zoom or LinkedIn or wherever you happen to be watching, feel free to drop them in the comment section. We have Serena also on this session who'll be answering those questions as we go, and then we'll pick out a handful to talk about at the end as well. So network as a service and Megaport, just to set the scene a little bit. Megaport's a network as a service company provider. So what we do is we run a large global network, and we have a bunch of interesting things connected to that network that our customers can reach over that service. So the idea is you connect to Megaport's network at the edge from where you are, and then you can reach out to any of these service providers or other data centers or customers or whatever you might need to get to via Megaport's global private backbone. And as you can imagine, one of the most popular things to connect to over that are the hyperscalers, cloud providers, and Azure is obviously one of those that we have connectivity into. And that connectivity is via ExpressRoute. So ExpressRoute is Microsoft's private connectivity product to allow you to kind of physically plug into Azure over a private path and not go over the internet. So the first thing we'll go through with regard to ExpressRoute is how the components are kind of arranged. So there's three different types of physical locations that are involved. There's the ExpressRoute location, which is where you can physically connect to Microsoft, basically, where they physically have an edge device that you can plug into. There's also the Azure regions, which are the groups of resources where you can deploy workloads. So they're the ones you'd be familiar with seeing in the Azure portal, where you can choose to deploy the actual services and workloads. And then those Azure regions are grouped into what Microsoft calls geopolitical regions. Often those geopolitical regions are pretty broad. So North America, for example, is one geopolitical region, the whole lot. Europe is one geopolitical region. But they're not always quite as clear as that. So I've got some examples here from APAC just to sort of illustrate the point. So there is one geopolitical region, which is just called Asia. And that includes the East Asia and Southeast Asia regions, and it includes the list of ExpressRoute locations you can see on the right-hand column. Japan is not part of that. So for the purposes of ExpressRoute later on, it's just important to bear in mind that the geopolitical regions are not always arranged in the way you'd expect. Similarly, there's a geopolitical region of Oceania, which includes Australia East and Australia Southeast, but does not include Australia Central, which is Canberra. So that's something to check when you're going to look at ExpressRoute is where is the ExpressRoute location? What region are you trying to connect to? And what's the geopolitical region that's all grouped into? So to look at ExpressRoute itself and what the actual technical components are, starting from the left-hand side, which is essentially the customer, so that's where you are. You have your equipment. In our case, that'll connect to a Megaport port, which gets you access to our network. Across that network, you'll have a virtual cross-connect, which is a point-to-point layer 2 link to Microsoft's Edge. And that connects to the ExpressRoute circuit that you create in Azure portal. So to look a bit deeper into the ExpressRoute components themselves, when you log into the Azure portal, you'll create what's called an ExpressRoute circuit. The ExpressRoute circuit exists at an ExpressRoute location, and that ExpressRoute location is associated with a particular Azure region. So the ExpressRoute circuit is not a single link. The circuit is actually two links. So when you order the circuit, you choose the location. So let's say you choose the Sydney location, or Sydney 2, or Melbourne, for example. Within that location, Microsoft run two different sets of hardware, two different sets of devices, and they'll provision you an interface on both of those. So the one ExpressRoute circuit actually includes two links, a primary and a secondary. So that's why I've got two on this diagram here. So this is, although there's two links, this is one ExpressRoute circuit from the Azure perspective. That ExpressRoute circuit, which exists at the ExpressRoute location, then has built-in connectivity via Microsoft's network back to the Azure region. And then from the customer side, the way that you interact with that is in the Azure region, you'll create an ExpressRoute gateway, and you'll attach this ExpressRoute circuit to that gateway. The gateway can then have what's called a connection, which connects it to a VNet. So those are the components. So starting from where the customer is, there's the ExpressRoute circuit at the ExpressRoute location. That's connected, which includes two links. That's connected back to the region where there's an ExpressRoute gateway, or virtual network gateway. And then from that gateway, there's a connection which attaches to a particular VNet or multiple VNets. So there's a couple of things that come up pretty often here regarding high availability. As I mentioned, the one ExpressRoute circuit does include two links, a primary and a secondary, on two different devices within the one ExpressRoute location. And the one ExpressRoute location, it typically refers to a single data center. Sometimes customers are concerned about the availability of that, so they don't necessarily want to have a reliance on that one ExpressRoute location, that one data center. So they want to split that connectivity across two locations. So you can do that. The architecture we've got here basically shows two ExpressRoute circuits, one at each of two different ExpressRoute locations. And as I mentioned, each one includes two links. In this case, we've got connectivity to one link of one ExpressRoute circuit at one location and another link to another circuit at another location. This is possible. You can do it. It does work, but there's some pretty big caveats. There's some pretty big reasons that you might not actually want to go with this architecture. The first one is that Microsoft expects you to have both sides of the circuit up, both the primary and the secondary. So there's some other things that are based on that. So the SLA that Microsoft provide is 99.95% for the ExpressRoute circuit. And that applies to the circuit as a whole. So it applies to the pair of connections in aggregate. So one of those links, one of those connections could be down for the entire month, and it still meets the SLA as long as the other one is up. So there's no particular SLA that applies to the individual connections. The SLA applies to the circuit in aggregate. Secondly, if you have both of those links up, the primary and the secondary within the circuit, you can run ECMP across those. So you can have active connections, and you can distribute the traffic across both. And under normal circumstances, when both links are up, assuming there's no outage or maintenance event, you can actually use double the bandwidth. So if you have a 1 gig ExpressRoute circuit, you connect to the primary and secondary, you can actually push 2 gig of traffic across that link, as long as there's not any maintenance occurring or there's no outage currently in place. Also, ECMP means that if there is a maintenance or outage, you only lose half the flows, so it reduces the impact when there actually is an outage event. Secondly, the reason you might not want to do this, as in split a connection across two different locations, is that within a location and within a circuit, the failover time between the primary and the secondary can be very fast. You can run BFD, bidirectional faulting detection, against these endpoints. And in that scenario, you can fail over between the primary and secondary in about 1 or 2 seconds. So you'll have about a 1 or 2 second outage. If there is an outage, if there's a maintenance event, to flip over from the primary link to the secondary within a circuit. If you need to fail traffic over from one ExpressRoute location to another, or one circuit to another, there's a much longer outage period. There's a 30 to 90-second failover period to route traffic out via a different ExpressRoute location. So as much as you're covering the fact that if one location goes down, you've got another, in the much more common and more likely event that there's small outages or maintenances of individual circuits, you'll have a much higher outage each time. So it's possible, it does work. There are some customers who their particular profiles can work with this, that they prefer this architecture. But for the most part, you're better off to connect two links, the primary and secondary, to the one ExpressRoute location. And if you need more availability than that, bring up another ExpressRoute circuit and connect both links of that circuit as well. So the other part here regarding options for ExpressRoute is the SKUs, or the different tiers of connectivity. So there's 3 different tiers. I've split them out here in this table. They're basically arranged by price functionally. So most customers that we work with typically will use standard. It covers most use cases. It's the most cost effective. So a standard ExpressRoute circuit will give you access to all of the regions within the geopolitical region, right? So if you have a standard ExpressRoute circuit in either Melbourne or Sydney, you can access either Melbourne or Sydney. Likewise with the Asia region that I had in the first slide, if you have an ExpressRoute circuit in any of those locations, you can access the Asia East region and the Asia Southeast region because they're in the same geopolitical region. With a premium circuit, one of the big differences is that you can access any region globally. So in some cases, customers need to use premium because they want to connect from, let's say they have an ExpressRoute in Singapore, but they want to connect to a region in Europe. You can use premium to do that, right? You get access to all regions globally. The other reason you might go for premium is that you can advertise 10,000 routes via premium, whereas with standard, you can only advertise 4,000 routes. So if you have many routes that you need to advertise from your on-premise environment into Azure, you may need to look at premium for that as well. The other big difference is whether the connection is metered or unmetered. So standard and premium, you can choose whether it's metered or unmetered. Local is always unmetered. Local, compared to standard and premium, only allows you to access the one single associated Azure region. So if you get a local ExpressRoute service in Sydney, for instance, you can only access the Australia East region. You can't access any other regions, only the one that's associated. And not all ExpressRoute locations have an associated region. But if you do need to move lots and lots of data, sometimes it is the cheapest option, the most cost-effective option. Standard and premium work the same way I described earlier, but you can choose to have them unmetered, in which case you don't pay anything per gig for egress data. The caveat to that is the hourly cost for the service is much higher if you choose to not pay per gig for usage. So it's really just a matter of which one fits best. Do you need access to just the local region, or all regions in the geopolitical region, or all regions globally? Do you need to have many routes advertised from on-prem into Azure? Or what kind of data are you going to move? Are you going to move heaps and heaps of data? And do you kind of get to the break-even point where you'd be better to pay the significant additional cost per hour for unmetered because it'll cost less than the actual usage charges due to the amount that you're moving around? All right. So now what we're going to do is jump into the Azure portal first off and create an ExpressRoute circuit, and then we'll come back to the Megaport portal and show you how you can connect to that circuit. So this is the Azure portal. In here, we'll go to ExpressRoute. If you don't have that button there, you can search for ExpressRoute and find it. So this will list all the ExpressRoute circuits that you have in place. So we'll create a new circuit. So we'll choose the region that we want this circuit to be associated with. So we'll go Australia East for the demo here. Give the circuit a name. We'll choose a provider. Okay, so we'll choose Megaport as the provider. There is a different type of ExpressRoute that is available that's ExpressRoute Direct. Nearly all customers that we work with will use the provider version, but we do also support the direct version. There's some pros and cons with that, but it tends to be a little more niche, so it's probably outside of the scope for today. You can then choose the peering location. So this is the ExpressRoute location that I mentioned earlier. So in this case, we'll choose Sydney. So in Sydney, there's 2 on-ramp locations. There's Sydney and Sydney 2. There's not always 2. In Melbourne, there's only 1. So you just basically have to see what's available in the locations that you need. If there's 2, you can use that for increased availability and bring up a circuit to each. So we'll choose Sydney for this one. You can choose the bandwidth of the circuit here. We'll just go with a 50 meg circuit for the sake of the demo. And down the bottom here, you can choose between standard and premium, which is what I discussed earlier, or you can choose local in some cases if you're using an on-ramp location that has an associated region. You can also choose the billing model, whether it's metered or unmetered, which is also what I mentioned on the last slide. All right, so we'll hit create. So this will go off and create the ExpressRoute circuit. Basically, once this circuit is created, you'll get a service key, which is a GUID that you can use to paste into the Megaport portal, and that's what you can use to associate the connection you create within Megaport with this particular ExpressRoute circuit. Okay, so we'll jump over to the Megaport portal. So this is the Megaport portal. This is sort of the dashboard view that shows all of the enabled locations. So we'll jump over to the services tab. We'll create a port first off. We'll create a port in, let's say, maybe next DC S1. So we'll choose the data center. So this would be the data center that you're in. So we'll choose a 10 gig port. So we have 1 gig, 10 gig and 100 gig available here. So we'll choose 10 gig. We'll call this demo port. Okay. So we've added that to the cart here on the left-hand side. So we'll order that port, order now. So the ports, basically they provision straight away. It takes about 60 seconds for the port to be created. And then that's all ready to go in your data center. So that's basically how you get access to Megaport's network that you can use for whatever you happen to be doing. In this case, we'll be creating an ExpressRoute circuit, but the process is exactly the same, whether it's to AWS or Azure or Google Cloud or another data center, wherever you might need to go. So that port's provisioning now. Okay, so that's done. That port's all provisioned and ready to go. So the next steps from a practical perspective here would be to download the LOA and use that to order a cross connect from your rack to plug into this port. For this demo though, what we'll do is we will say we want to create a connection from this port to Microsoft Azure. And here we've got the field where we can paste in the service key. So if we jump back to the portal here, Azure portal, let me go to resource. We can see that in here, we've got the details of the service we just created. So it's the Australia East region, it's the Sydney ExpressRoute location. And here we've got the service key. So this is the service key for this particular ExpressRoute circuit. So we'll copy that. We'll go back to the Megaport portal and we'll paste in the service key. So that service key is all ready to go. And you can see here that these are the locations where this ExpressRoute circuit is being provisioned. So we've got a primary and a secondary, as I mentioned earlier, as part of this one single circuit. And this is sort of how you can choose which one you want to connect to. So from this port, we'll choose we want to connect to the primary circuit. Yep. I just checked up here. This is a bit of an aside, but generally best practice is you'll match the diversity zone of the port that you have with the diversity zone that you connect to. So this port up here is in the red zone, so we'll connect to the primary ExpressRoute side in the red zone, and we would connect to the other on-ramp in the blue zone from a port in the blue zone, typically. It is possible to connect to a single port, but for high availability, it's sort of better to have diverse delivery. So we'll give this a name, ExpressRoute 1, and we will choose, we can auto assign a VLAN, we can specify the VLAN that we want this delivered as there, and we'll go next, add VXC, and order. So this will validate the order, and then this will go and build that point-to-point layer 2 link from the port in your data center to the Microsoft on-ramp to the ExpressRoute circuit that you've just ordered. So we'll go order now. So this is all real, right? This is not a simulated environment. This is the real Azure portal and the real Megaport portal. So this is kind of really the time it takes. It's pretty much all on demand and ready when you are. So this service won't actually come up because the port itself is not physically plugged into anything, obviously. But that's pretty much the workflow. So from here, once this is synced back to the Azure portal, which typically takes a minute or two, you can come into the Azure portal and configure the circuit itself. So you'll see here that it says initiate the provisioning process with your service provider. So after a minute or two, that little flag there will disappear and the status here will change. So we can refresh this, see if that's updated already. Yeah, so it's starting to say provision. So it'll take about a minute or two to come all the way through. But basically that's the process. So you now have an ExpressRoute circuit that's there and set up and ready to use. And you can go through the process here of configuring the peerings, configuring the IP addresses that you want to use, whether it's public or private or both. And then using the connections field here to connect it through to your ExpressRoute gateway into your VNets. So the way that these settings work, the peerings section is the part that goes off to the left in the diagrams from before, so off towards your data center. So this is peerings between the Microsoft Edge and your equipment, and the connections go the other side towards the right. So they go from the ExpressRoute circuit into your ExpressRoute gateways and your VNets within Azure. So that's pretty much it. So we're ready to go. We've built that ExpressRoute circuit, and that's if we were to physically plug this in the data center, that's all up and running and ready to go. As quick as that. As I mentioned, for high availability, we typically recommend that you have a second port delivered in the other diversity zone. So this is in the red zone. You could order another port in the blue zone and connect that to the Microsoft on-ramp in the blue zone. So you have completely diverse paths and you have full redundancy of the circuit. It's also possible to connect to both private and public services via this ExpressRoute circuit. So in the configuration for the circuit, you can configure either private peering or what's called Microsoft peering. So private peering will allow you to connect into your own services, so into your own VNets, basically. Microsoft peering will allow you to connect to Microsoft's public edge and receive public routes for the sort of external public facing services within Azure. So anything that uses a public IP address within Azure, you'd use that workflow. You can run both over the same link. You can use Q and Q. So by default, Microsoft do use Q and Q. So they use 2 levels of VLAN tagging. We do have some functionality in here that can allow you to sort of choose how you want to deal with that. So it doesn't really matter too much. You can do whichever you prefer. You can have this service delivered directly untagged on the port, you can have it delivered as a tagged VLAN, or you can have it delivered as a double tagged Q&Q VLAN, so one VLAN within another. Either way is fine. You just basically configure that in here. And that's that. You're all ready to go. So, Serena, were there any questions online?
Yes, Ryan. Yeah, there is two questions online. Yeah. So the first question is, does ExpressRoute support MACsec encryption?
Okay. Yeah, okay, that's a really good question. So the short answer is yes. The caveat to that is because of the way that MACsec works, and because it encrypts the VLAN tag by default, there's some extensions around that, but under normal circumstances, it encrypts the VLAN tag and it's configured at a port level. In order to use MACsec with ExpressRoute, you have to use ExpressRoute Direct, which is the version of this where you have a dedicated physical port assigned to you within Microsoft's network. So you can do it, and we do support it, and we do have customers that use it. Just bear in mind that if you do want to use MACsec, you do have to use ExpressRoute Direct. So the architecture is slightly different. Most of the stuff in here still applies, but the architecture is slightly different as far as the physical connectivity piece. What I would say though is probably most of our customers don't use MACsec because most of our customers will use something like TLS and already have application level encryption in place, or they'll use IPsec over the top. Typically, when customers want to use MACsec, it's because they really need high capacity. They sort of need 10 gig per second plus of throughput, or they at least need quite a few gig per second of throughput. And so they'll go down the path of MACsec. But at any rates lower than that, it's typically easier to use IPsec over the top and more cost effective. And also consider that you may already have encrypted traffic. You may already be using TLS, and often implementing TLS at the application level, if possible, can be kind of a more scalable and end-to-end type approach to encryption. But yes, we do help customers use ExpressRoute Direct to use MACsec.
Yeah. Thanks, Ryan. Yeah. So I got one more question. So can ExpressRoute be used to connect to virtual WAN?
Yeah. Okay. So yeah, it can. In the examples here, we've basically shown ExpressRoute connecting to a VNet, but that's really just because that's the most straightforward deployment. If you were to connect to vWAN, it would basically look exactly the same as this, but on the very right-hand side, you would have that gateway associated with the VNet hub rather than an individual VNet. All the other parts pretty much work the same. All the locations and regions and everything all work the same. The availability and SLAs, everything's all the same. The only difference is that if you're using vWAN, you may have less of a need to use ExpressRoute Premium because you can use ExpressRoute Local or Standard to access the vWAN hub and then use vWAN to route globally. So you may, if you're using vWAN, you may not need to use Premium, even though you need to access remote regions globally because you're kind of already covering that use case with vWAN. But otherwise, it's pretty much the same architecture. You would just have vWAN on the right-hand side instead of an individual VNet. All right.
Okay, thanks, Ryan.
Cool. No worries. Thanks a lot. Okay, so that's right on the half-hour mark. So that's pretty much all for today. So thanks everyone for coming or watching. I think we're posting these to YouTube now as well. So feel free to leave a comment or questions or anything. We'll basically use those to drive the topics for the next sessions. Do them every week. So yeah, check back in and thanks for watching.